Hello everyone. In this video, I'm going to talk about one of the important applications of RMS values. Which is calculating the effective current. This is probably the most important application of RMS value in the electrical technology. First question is, what is an effective current? An effective current is defined as the constant current that would result in the same amount of power in the resistor as some time varying current would have averaged over time. It's always equal to the RMS value of the current. Let's do one example and I'll show you how to figure out the effective current in this case. Let's say a current I is given by the triangular waveform which is given here, and the power dissipated in a 1 ohm resistor. This is a graph of our I, and it is a triangular waveform, and this current flows through 1 ohm resistor. We have to calculate the power. Find the power dissipated in a 1 ohm resistor. From your physics class, you know that power is given by I square R, where I is current and R is the resistance. Since in this case, R is given to be 1 ohm, so therefore the power should be I square times 1, which is I square. Our power function is I square in this case, and we are given the second graph, which is the graph of I square, in other words, which is the graph of our power, which is varying over time. Usually we are not interested in the rapidly varying details of P, but we only interested in the average over time. What is the average power P over time? In this case, we are interested in the average value of P, or in other words, the average value of I square. And if we look at the graph of I square, we notice that here we have the repeated parabolas, a whole series of parabolas, and all of them are symmetric. And we can divide each shaded region into two parts, and we see that all of first part is equal to second part, third equals to 4. Basically these all shaded parts are same, they are symmetric, so it means we can only deal with the interval 0 to 1, because by symmetry the average for each interval gonna be the same. Average power of P over the interval 0 to 1 is given by 1 over 1 minus 0. Recall the formula was 1 over b minus a, integral of fx from a to b. In this case we do 1 over 1 minus 0, integral from 0 to 1 of our function. If we look at this parabolic function, the equation of this function is 100t square from 0 to 1. We get 100t square dt. Thus we get 1 and then 100, and then integral of t square is t cube over 3 from 0 to 1. Overall we get 100 over 3, 1 cube minus 0 cube, which is 100 over 3. That is our average power, or the mean power, or the mean of I square. This is our mean value of I square, which is 100 over 3. So far what we did in this problem is we have figured out the average power, right? The power that is dissipated this in 1 ohm resistor. We have answered what question was asked to us. Find the power dissipated in a 1 ohm resistor. So let's make some observations about the effective current now. Since we know that effective current is the constant current that flows through the resistor and that would dissipate the same amount of power. So that would be our effective current and we can call it I effective. So therefore the power should, in the above example, it should be I effective. So effective current square times R, and in this case we already found that the average power is 100 over 3, so 100 over 3 is equal to I square. So I'm just writing the effective current times R, so resistance is 1 ohm. From here we found that square of effective current is 100 over 3, or in other words, effective current is equal to square root of 100 over 3. So now if we do the comparisons of our previous solution, so we got 100 over 3 here as our mean power, or so if we look at this, and then where did we just get this 100 over 3 is from here. So I'm just going to combine all this together and see what we get. Since we know that, so I effective current is equal to square root of 100 over 3, and here we got 100 over 3 using this function. So I'm just going to use square root as it is, and in place of 100 over 3, I'm going to write the highlighted part. So we get this equals to 1 over 1 minus 0 and integral from 0 to 1. And what is our 100t square? So that was our I square function or our power function. So I square, which is a function in terms of t, dt. And if we look closely, so this is our root mean square value of I function. So it means effective current is equals to root mean square value of the current function. So from this example, it is clear that the effective current is always equal to root mean square value of the current. I hope that makes sense. In the next video, I will talk about the mean and RMS values of periodic waveforms. Please do watch that video as well. See you again.